Welcome, ladies and gentlemen. My name is Jonathan Kays. I'm a Natural Resource Extension Specialist with the University of Maryland Extension. I work a lot with woodland owner programs and professional training and things related to that. I'm here today to give a presentation on the environmental safety of forest herbicides. I assume that you're tuning into this because you have an interest in using herbicides, but may be a little apprehensive about how to use them and what to use. So in this presentation, I am going to have a couple of objectives. First of all, the use of forest herbicides and potential effects on the environment and humans, and how to obtain the benefits of forest herbicides and minimize any potential adverse effects. And then thirdly, to ensure that forest applicators are using chemicals safely and effectively. Much of the need of this program has come because with the influx of a lot of invasive species and things like that, we're finding that really the use of herbicides, forest herbicides, is really essential in order to have any type of really serious impact on invasive species and things like that. So people are asking a lot of questions and very concerned about the different effects on the environment and humans and so on. Excuse me. So we're going to kind of cover a lot of those things here today, and I think you'll get a lot of those questions answered. Since this is pre-recorded, there is no chat. But if you would like to contact me, you'll find my contact information at the end of the presentation. Thank you very much. First of all, let's just talk a little bit about the development of herbicides. Much has been developed through companies coming up with pesticides to address specific issues. And it's important to understand that pesticide is an overall category which includes different types of pesticides, of which herbicides is one that affects plants, insecticides, which affects insects, and rodenticides, which affect rodents. And so just to understand that, much of what we know comes from the Federal Insecticide, Fungicide, and Rodenticide Act, known as FIFRA. And we keep coming back to the label here, which we're going to talk about, but on how these materials can be used and under which conditions, to answer some of the basic questions that some people may have. And one of the questions that comes up is regard to labeled sites, that are listed on the label. So can a pesticide be labeled, can be applied to a site that is not on the label? And a site would be, for example, like forest or agriculture, for example. So the answer is, can it be applied to a site that's not on the label? And the answer to that question is, of course, no. Pesticide could be only applied to labeled sites. So if it says forestry, forest only on the label, they can only apply to sites that are forests, not to agriculture. That would require a different designation, and the reason for that is that the research and the testing that is done of these things have been done addressed to those specific sites. Now another question that comes up is, can a pesticide be applied to control a pest that's not specified on the label? And the answer to that is yes, provided the pest is found on the labeled site. So an example like this would be, let's say we have a pesticide, like a herbicide, that is labeled for forest. And it lists on the label a number of different tree species and things that are can be used to control. But it doesn't mention one. An example of that would be, for example, tree of heaven, or lanthus, which is a very aggressive invasive. And even though it may not be listed on the label, which in many cases it may not be, as long as it's in the forest, it can be used on that pest, okay, on that species. So there is some, latitude and flexibility there. Another question that comes up is, can a pesticide be applied at a higher rate than labeled? And I think this is probably a fairly obvious question. The answer to that is no. I mean, the research that's been developed, has found that at what level do you start to get negative impacts and built-in safety factors, so much we'll talk about in a little bit. The fact is you don't want to go over the applied rate. And that being said, in many states like Maryland, a pesticide may be applied at a lower than labeled rate. The other thing is labeled application methods. There's different types of application, aerial, applying a foliar application, or onto the soil and so on. And the question is, can any method of application be used? And the answer is yes, as long as it's not prohibited on the label. So, for example, a herbicide may say that aerial application is prohibited. But that means that we can use all the other kinds of applications. So we could use ground application methods, and things like that. It's just that it specifically prohibits aerial application. So, and one of the materials we have is known as Tordon, specifically states that it should not be applied to air. But it can be sprayed on the ground using a number of application methods. So again, all this information is on the label, so we're just kind of pointing out a few highlights here. Well, let's talk about vegetation control with forest herbicides and what are the benefits of using these materials and some of the concerns. The first question comes up, are they effective? Well, there's been extensive research and commercial work done that have resulted in very specific herbicide recommendations for controlling everything from different types of trees to ferns to grasses to many of your invasives. And indeed they are effective. They do work, and that's why they continue to be used. And like I stated in the point with many of our invasives, they're actually essential in some cases to actually to have them in order to have an effective impact on invasives, certain species particularly. The question that comes up, are they cost effective or are they economical? And they indeed are a cost-effective tool in forest stands. And I think that maybe about 10-15 years ago, a lot of people in native plant societies and organizations were very against herbicides, and have found that really, in order to have a serious impact on invasives, because they are economical and they are effective, they are recognizing the need to use judicious use of herbicides under controlled conditions. The other thing is risk. Well, most forest herbicides we use today are generally of low risk to the environment and to humans when used according to the label. And the point here is that say, well, I mean, people are concerned about that, and I'll point out why they are low risk. They say, well, let's use mechanical methods. And you have to ask the question, using mechanical methods such as saws and axes and so on are more likely to cause injury to workers, as well as damage to trees and to the future forest than any type of forest herbicide that's used according to the label. So in terms of actual low risk, I would argue that many of your mechanical means have a much higher incidence of risk, just due to the nature of the business of using tools and axes and things like that. So herbicides provide a practical way of removing unwanted vegetation and creating very little mechanical disturbance, and maybe the best choice in certain circumstances. The other question comes up, are they necessary? And like I stated earlier, I think I'll just repeat a little bit, they may be the only means for controlling certain vegetation. And again, I'll come back to my example of tree of heaven or lanthus, which you're better off not doing any type of control unless it's going to be chemical with herbicide, because just mechanical cutting of those trees is going to stimulate so much root sprouting that you're just going to have a million stems there to deal with. So the use of herbicide that's going to basically stop root sprouting is absolutely essential. And the whole point here, is it necessary to meet the objectives of what the land management objective is? And if it is to get rid of invasives, it is to thin things out without having to do mechanical treatments on trees. We can use a technique called hack and squirt, and other things which I'll describe here in a minute. So those are some of the 4 points to remember. And the question that comes up is, well, how much of this material is being used? We're very concerned about that. Well, just to give you an idea, in Pennsylvania, some numbers from there, in 2005, there were 15,000 to 20,000 acres of forest land or woodland in Pennsylvania was treated. 0.1%, maybe treated annually. Numbers from Maryland are much, much smaller. And I have some numbers I received from the Department of Forestry, the Maryland Department of Natural Resource Forest Service last year. They said there was approximately 3,338 forest acres treated, and about 322 acres treated for site preparation for planting pine typically. So that's about 3,660 acres. If you add that into I think there's about 2.4 million of forest land in Maryland, you get into a very low number, 0.01, something like that. So very minimal impact, and I think you have to compare that against the use for agriculture. And just as an example, if you look at a county just like Carroll County, for example, I looked up some numbers. 30,700 acres in corn, 7,538 acres in soybeans, or grain. Soybeans is 20,426 acres. Vegetables, 3,283 acres. Orchards, 517 acres, for a total of 62,574 acres. So almost all those properties are receiving, in most cases, some type of pesticide application in many cases. Now, I recognize there's a difference, I think you do, between agriculture, which is very focused, and forest environment, which has a lot of other qualities we want to protect. So they're basically, we have ecosystems and wildlife and things like that, but there's a lot more diversity in the forest. So we're very concerned about things, but the point here is that the amount of land that's really treated in forestry for forest herbicides is very small. And so my message here, and I'll have a few of these messages throughout, well, let me mention this first. The other thing is application rates. We're talking about very low application rates of forest herbicides, from maybe 1 ounce to 2 quarts per acre. And for most hardwood forests, there may be one type of a herbicide treatment throughout the 80-year rotation. And for pine, maybe 1 or 2. So very infrequent, very relatively small areas. Those are the things to remember. And in terms of a take-home message, forest herbicides are applied infrequently in small amounts to forests, and just by the points that I've summarized there from what I mentioned before. So very important to consider that. And I will mention in this slide as well that I believe the gentleman should be wearing gloves and a long sleeve shirt. So for those of you who mention later what the minimum attire is for for the use of herbicides, this person is actually not doing it, so I need a better picture. What are the different types of application methods? And here we get into, there's aerial application, which is, covers a very large area. And then we have foliar ground, where we have a sprayer and there's foliar vegetation. We spray that on the ground. Then injection, which is, even more focused, where you see on the left here, using what's called a hack and squirt method, where you have a axe and you make a cut in the tree wood about every 3-4 inches in diameter, and you have a spray bottle which you spray the material in, 50% Roundup or Garlon or one of those types of things, and it gets taken down into the tree. And you do this in the fall, and will basically kill the tree and usually stop any types of sprouting. So there's different types of application methods, and the point here, and there's also soil treatment, where actually some materials are Velpar is one of them, which is actually you put on the soil and it's taken up by the tree. The whole point here is that when you have a choice of application method, you want to choose the one that's the more localized. So aerial is necessary and good in many cases, but if it's possible for us to, economically and so on, we want to use the most focused, localized method possible, which would be your, get into the hack and squirt and, maybe foliar ground application. But it just depends on the objectives of the land management. Sometimes it's not possible to use those methods. Well, let's talk a little bit about toxicity. This is something people are concerned about. How toxic are these materials? Well, toxicity is a measure of a pesticide's capacity to cause injury or illness. And it's dependent upon two things, which I'll keep mentioning: the properties of the chemical and your level of exposure to the chemical. Those are the two most important things. So we can't necessarily control the properties of the chemical. We want to choose the chemical that has the least toxicity, but after that, really, the level of exposure depends upon, it's going to require really, depending upon our personal protection equipment and good use methods. So exposure can come from any four entry points. One would be ingesting it or eating it through the intestinal tract. And inhalation is breathing. Dermal absorption through the skin, and eye contact. So obviously the reason that the basic attire for spraying herbicides and forest herbicides is generally a long sleeve shirt to stop absorption through, on the skin, as well as gloves, some type of gloves, and a long sleeve shirt and shoes and socks. So Toxicity is measured in two ways. One is acute toxicity, and that's the ability to cause illness or injury within a short period of time, say within 48 hours after exposure. And the other is chronic toxicity, and that's the ability to cause illness or injury from repeated exposures, or illness or injury that doesn't show up for a long time. And this would be your example of cancer, which, asbestos is a good example. It doesn't show up for 20 years. You have small doses repeated over a period of time, and we want to manage those types of things and reduce the impacts. And we'll talk about that in a few minutes. Now, acute toxicity is expressed as LD50. LD50 is the lethal dose that it takes to kill 50% of a test population of animals under a standard set of typically lab conditions. So, and then lethal concentration for other things, for inhalation and things like that. But let's just talk about pretty much LD50 for 50% of animals, and it's recorded in milligrams of pesticide per kilogram of body weight that it takes for that animal, for 50% of the animals in that population to die. So we can blow that up, of course. We're doing this on smaller animals. That's what tests are, but basically you can blow that up to what it takes for the size of a human, and we'll have a couple of examples of that. And like I said, the lethal concentration 50 is the lethal milligrams of pesticide per volume of air or water. And we're not going to really talk about that much right here because it's usually LD50 that most people deal with. Now, that LD50 is the basis for assigning a signal word that you'll see on all containers. Whether it's going to say poison, whether it's going to say or danger, danger, poison, warning, or caution. One of those three options. So, let's take a look at what that really means. And these are the signal words. So every pesticide label must include a signal word, as well as the words "keep out of reach of children." And the way it works is that if it has a signal word of danger, that means it causes severe eye or skin irritation, it's highly toxic. Its LD50 is anywhere from 0 to 50 milligrams per kilogram of body weight. And I've asked this question in a class before: is it better to have a material with a low LD50 or a high LD50? And obviously it's better to have one with a high LD50 because it takes a lot more of it to cause the test animals to die. So 0 to 50 is very dangerous material, okay? Usually some skull and crossbones on it. And then we have a warning signal word, which means its LD50 goes from 50 to 500. And then caution is greater than 500 milligrams per kilogram. All right? So remember those three: danger, warning, caution. And it's also important to understand the signal word provides information about the likelihood of acute effects only. It doesn't have anything to do with chronic or long-term effects. So the fact is that something has a more acute toxicity, has really no chronic problems. So they are not necessarily related to each other. So the proper use of the signal word refers only to the likelihood of acute toxicity. And like I said, there's no similar label word to provide information about the likelihood of long-term or chronic toxicity. So your level of risk in using any type of pesticide is based on the combination of the product's ability to cause those acute or chronic effects and, of course, your level of exposure, which you have a lot of control over. Well, let's talk a little bit about chronic toxicity as well. And that measures, again, the potential of a chemical to cause long-term effects, and these are some of the ones that typically you associate with that. That would be things like cancer and effects on fertility, birth defects, nervous system, things like that. So the way chronic toxicity is measured is that they take rats or mice and they expose them to small doses over a 2-year period, which is typical lifetime for a rodent. And scientists make note of the lowest dosage that causes no observed effect. Okay, and then they divide that by a safety factor somewhere between 10 to 100. and they may have other safety factors they add in as well. And that's going to be, your the chronic toxicity, allowable, maximum lifetime dose for human exposure. Okay, so basically that's how it's determined. And so the point to remember is that once they do these tests and they find at what point there is, basically no effect, and then it goes to where there is an effect, they divide that by a factor of 10 to 100. So there's a large safety factor built into the toxicity of these when these tests are done. Well, what is the relative toxicity of some of these materials? And before I get on to that, I'll just state that really the herbicides that we use in forestry, you look through the literature, there's really not been long-term chronic effects associated with these materials. So that's important to remember. But we still want to make sure we err on the sides of caution, so we take measures to limit exposure. So that's the good news. Here's a couple examples of the relative toxicity of some common forest herbicides, and again, they're expressed in milligram per kilogram of body weight. And you can see that glyphosate, which is typically known as Roundup, has a signal word of caution, which means it's from greater than 500 milligrams per kilogram, but actually it's greater than 5,000. All right. Arsenal, which is used for aerial application, typically for site preparation, is or for releasing hardwoods, releasing pines from hardwood competition, also a caution wood greater than 5,000. And you see a list here of many of the chemicals we use in forestry. The one exception might be here triclopyr, which is what's in Garlon products. Has a little lower LD50 still, much higher than 500, but not as high as some of the others. And I kind of made a point of contrasting that with a couple of things that we commonly use in our everyday lives, and salt, for example, Tylenol, ibuprofen. And the point is that these things have much higher LD50s than herbicides. So, and then I did compare it with some insecticides, malathion, 7, which are some common pesticides that are used there, more insecticides for killing insect pests. And you can see they have relatively low LD50s, and that's because they're meant to act on the physiology of animals, which are very similar to our physiology. Unlike everything you see up here, and I'll explain this in a minute, is developed to affect plant physiology related to photosynthesis and chlorophyll and amino acids, which our systems, frankly, we just don't have. And of course, caffeine is on the bottom here, which is extremely toxic material, which many of you probably do know that. Give you an idea of what it takes, we talked about milligrams per kilogram of body weight that it takes to kill with the LD50, but what does that mean when you actually blow it up to the size of an average sized person? And you can see if something is a danger, which is the most highly toxic pesticide out there, LD50 is less than 50, from 0 to 50 milligrams per kilogram body weight. To kill a human, you're talking about a taste, maybe 7 drops to a teaspoon. Not a whole lot of that material. Warning, 50 to 500, and you can see that goes up to a teaspoonful to an ounce. And all the materials here are using greater than 5,000 milligrams per kilogram of body weight. You're talking about greater than a pint. So this would be material on the counter. For those of you who know what Roundup is, it would be like drinking more than a pint of Roundup. And you just can't even imagine that. So these are relatively low toxic materials that we're using here. Go through that. So the message here is that forest-labeled herbicides, they're low in acute toxicity, and chronic toxicity is hard to measure and measure differently, but most of the research that we have shows that these materials are not have really any problem with chronic toxicity. And I think that's a really good thing to know. And many times it's because they've been developed to address specific biochemical processes unique to plants. And I'll explain that in a few more minutes, like right now. So forest herbicides and mode of action. So the question is, how can products with such low acute toxicities be so effective at killing plants? And like I said, the reason lies in the fact that they work on biochemical pathways that are specific to plants. And we're talking about the basic biochemical process in plants is things that photosynthesize. So many of these compounds are designed to inhibit photosynthesis, mess up some type of cycle involved with that, with amino acids, which are used to building blocks of many cells, and the residents develop those pesticides based on their mode of action against the pests. Just to give you an example of glyphosate, which is typically more known as Roundup, but comes in many other forms now. It inhibits the production of material synthase, which is essential for the production of 3 amino acids related to protein and to photosynthesis. So we don't have those materials in our biochemical pathways. That's the important thing to remember. And this is a listing of mode of action of with the number of the different chemicals, herbicides that we use in forestry. So 2,4-D and triclopyr, triclopyr being guaiolon, 2,4-D. Auxin analogs mimic plant growth hormone auxin, resulting in disorganized growth. So it messes up that hormonal growth in plants. Mitosis inhibitors, pendimethalin, which is known as pendulum, and some other materials. Photosynthesis inhibitors, hexazinone, atrazine, amino acids, so on and so forth. So the point here is that these are the modes of action. They're biochemical pathways found primarily in plants, and that explains why these materials, for the most part, are relatively low in toxicity. So pesticides, and again, herbicide being a type of pesticide, like any other chemicals, can have side effects. And we do want to be careful about that. And you can make an analogy to prescription drugs. We take prescription drugs. There's been a lot of research done on that prescription drug to find out its mode of action, what it works, what dosage should be, so that you don't have any, so it solves the problem. But in many cases, there may be side effects. Some cases not. So, with herbicides and pesticides in general, there can sometimes be side effects if we don't use them properly. So we want to use them properly. I think that's the and if there are going to be some side effects, we have to plan for them, and they have to be balanced against the benefits that we're receiving of using the material. Now, consider the signal word. The greatest risk arises when handling concentrates, mixing and loading. Personal protection equipment is what you're wearing, all right? And it's going to vary depending upon the signal word and on the label of the chemical that you're using. So all forest herbicides require a long sleeve shirt, long pants, shoes, plus socks. And so there may be some additional requirements regarding chemical resistant gloves and eyewear, and these other things that are mentioned as well. There's a couple different classification of chemicals as well. Every pesticide is classified by the EPA as either a general or a restricted use pesticide. General use ones can be used by homeowners on their own property. It doesn't require any type of certification through the Maryland Department of Agriculture. However, if anything is done for hire, it requires certification. So, for example, if you're using herbicide on your property, that's fine. There's no problem. But if you can be using general use herbicides, which makes up the bulk of them, really most things that you can buy in most places, and you're going to be doing it on someone else's property, it does require certification in the state of Maryland. And most government agencies, it's also required. Even though they may be using Roundup on a state park, they're typically going to require certification, and that's just kind of the way it works. Now, restricted use herbicides, or pesticides in general, have determined the EPA has determined they can be harmful to wildlife, humans, or the environment, even when used according to the label directions. So, because they're a little more, hotter, as they would say, or you want to make sure that they're handled properly, these require a certification. And the following statement on the label that you see here: for retail sale to and used only by certified applicators or persons under their direct supervision, and not for those uses covered by, and only for those uses covered by the certified applicator's certification. So, for example, some of you want a certification for rights-of-way or for horticulture. I can't remember what the exact categories are, but there's a number of them, and so they're based out on the category. Now, in our case, there's very few forest herbicides that are a restricted use. Virtually all our vegetation control needs can be accomplished through the use of general use herbicides. Oops, and I can see I missed my slide overtook here, but picorum, which is found in Tordon, is one of the ingredients that has a restricted use classification. And the Department of Agriculture, I believe on their website, Maryland Department of Agriculture, has a list of all the restricted use herbicides or pesticides in general in the state of Maryland. And the reason for Tordon is because it's known it's toxic to non-target plants at very low concentrations, and primarily through root uptake, because it's pretty mobile in the soil. So that's the reason that there's a restricted use classification on that. Well, the one other thing that people are concerned about is the effect on wildlife, and this idea of bioaccumulation. In other words, you put this material down, it gets onto leaves or into a tissue, wildlife eat it, or insects or bugs, and it accumulates in the food chain. But to put your mind at ease, this really just does not seem to be an issue with silvicultural herbicides. In other words, herbicides used to grow forests and trees. Because, one, they don't remain in the body. Most of them are out of there by 30 to 45 days, half-life of them. And they show no tendency to accumulate in the food chain. So this is really not an issue. Many of them are bound up by the soil particles and so on and so forth. So there's just not these long-term impacts on wildlife and problems like that. So the other issue is the real effect on wildlife, and the real effect that in many cases they're used is because their effect on habitat modification. They're used to delay plant succession. By killing the trees or vegetation that's there, it's kind of delaying development of that vegetation as it kind of gets older. It may also reduce food and cover the first season. And there's a wide variety of biodiversity objectives that can be met using herbicides, which may actually increase the amount and the diversity of a herbaceous species, which affects the diversity of wildlife. So that's the real benefit here, is habitat modification. I wouldn't be too concerned about these bioaccumulation effects. It just doesn't seem to be the evidence that that is a problem. So the effect on wildlife, basically forest herbicides are unlikely to cause acute effects to wildlife that consume plants. It just doesn't really seem to be a big issue. And move on just a little bit. The other thing is an environmental fate, and that is this idea of what happens to the material once it's sprayed. You know, how long does it hang around? And that's this idea of pesticide degradation. The breakdown of pesticide molecules into simpler, less toxic compounds like carbon and oxygen and so on. Very simple molecules. Photodegradation can take place in a couple of different ways. Photo, in other words, as soon as this material gets there, the sun starts acting on it, and it starts to photodegrade just by the act of the sunlight. The second is microbial. In other words, microorganisms like fungi, algae, using the pesticide as a food substrate, which to grow tissue and to grow material they can use for food. And this can be pretty rapid, and under favorable conditions of warm temperatures, and favorable pH levels, and so on, adequate soil moisture, this microbial degradation can go on very quickly. And finally, the chemical degradation, which is another one. And that's breakdown by processes not involve living organisms. This has mostly to do with what's in the native soils. Many soils that have a higher percentage of clay are more likely to absorb these molecules and hold them fast and stop them from moving. So pH is a factor, and temperature as well. So those are the types of degradation. So what about persistence? Well, the studies that are out there show that the half-life, that's the time needed for half the amount applied to decompose. For glyphosate, they're all around 40 to 60 days, somewhere in there. So these are relatively short-lived materials before they're broken down by those various degradation processes. And So degradation subject to the process of biological decomposition. That's what we just mentioned. The one thing that we are concerned about is movement, off-site runoff. And because even though this material may be bound up in soil tissues and so on, we don't want it running off into areas where it shouldn't be. So, because it can be a factor in pollution, and you have heavy rains and things like that. So, in many cases, it could be said that using herbicides, you're going to have a whole lot less runoff that would occur than if you had mechanical site preparation. And of course, leaching is another issue. Those materials, they're more leachable, of which Tordon's one of those. Picorum, is the movement of water through the soil. I want to minimize that. We want them to be held strongly by the soil particles. So the more clay, the more likely that is to occur. So the environmental message here is, when properly applied, forestry herbicides do not persist very long or move very far. So let's take a look at the list of points that we've talked about here today. First of all, forest herbicides are applied at very low rates, ounces or quarts per acre, and they're usually applied once, maybe twice in a rotation. Hardwood rotations would maybe once, pine maybe twice. So very infrequent, especially compared to agriculture, and very low in acute toxicity. Matter of fact, described as slightly toxic, greater usually most of them than 5,000 milligrams per kilogram of body weight, which is very, very low. Now we know chronic toxicity is hard to measure, but the evidence out there says it's unlikely to cause acute effects to wildlife that consume plants, because it is eliminated from the body in a very short period of time. They are biodegradable, very short half-lives, and degraded by microbes through a number of different processes we mentioned. And they pose negligible human health risks. And it should be mentioned again that if you're not using herbicides, you're probably using physical tools and things like that. So this is safer than manual methods of control, I would have to say. So the basic concerns here is, first of all, to limit the treatment area. By maximizing untreated area, you minimize potential effects on wildlife, habitat, and people, and use the most localized application later, and use the lowest dose possible to use the job. Don't use it if you don't need it. 2 ounces is good. That doesn't mean that 6 ounces is 3 times as good. That thinking has got to go away. So in general forestry practice and the herbicide used in forestry minimize impacts, but we want to be careful. In terms of pesticide certification, if you are anything more than just a homeowner using it on your property, if you're doing it for hire, you work for a government agency, things like that, then you would need to get a certification. It's not that big a deal. It's a relatively easy test. Department of Agriculture can help you out with that. Also, your local University of Maryland Extension office has a number of education materials that are available that you may want to consider. And for your most up-to-date, where your local extension office is located, well, first of all, you just go to www.pesticide.umd.edu, and I think you'll find all the information that you need there about how to do that. Applicator certifications for commercial and public agency applicators. There's core areas. There's also one for pesticide business license. And then there's a private applicator. And this is one, even if you're just a private landowner, it's not a bad idea to take. It just makes you aware of the things that you need to know. Well, of course, we have to give our disclaimer about trade names, as I've mentioned, and make sure to tell you, read the label, read the label, read the label. Most of your questions are out there. I'm sure they are. In terms of resources, I've listed a couple here. The first and the third one I think are the most useful. Herbicides and Forest Vegetation Management, Penn State, is a great publication. If you just Google, forest herbicides, Penn State, I think it'll come up. It's a booklet. It's made for basically the practitioner. Lots of good pictures, instruction on how to do things, and then the manual herbicide application methods for managing vegetation in Appalachian hardwoods. Now they say manual, but it may be manual using chemicals. So we're not talking about aerial application here. Very nice little field handbook, very sturdy pages, very much worth tracking down. I think if you just Google U.S. Forest Service and maybe I'm not sure if you would do that, but you could do that, and I think you could find it. Manual herbicide application, Forest Service would probably get you there. Very good practitioner book for the field person. So at that point, if this was a live webinar, you'd be able to submit some questions. But in the meantime, you see my email address down at the bottom, jks@umd.edu, and my phone number. If you wish to contact me, do so. I also make you realize about a month ago, we changed over our website to a new website, which is www.extension.umd.edu/Woodland. So again, if you just look for University of Maryland Extension Forestry, I think you'll come to it. But with that, I would just like to say thank you very much. I appreciate you attending today, and if there's any way I can help you, please let me know. Thank you very much.